Now let us see how we can solve part B using method 2. So method 2, which is a method of perpendicular lines. Part B says that find the equation of the tangent to the circle 2x squared plus 2y squared plus 9x minus 4y plus 4 equals to 0 at the point of tangency -2 and 3. The method of perpendicular lines requires us to find the coordinates of the center. So since we are going to find the coordinates of the center, we must make sure that the coefficients of x squared and y squared are both 1. So without wasting time, we divide through by 2, dividing all the terms by 2, so that we make the coefficients of x squared and y squared 1, positive 1. Okay, that is 1. So on dividing through by 2, we shall have x squared plus y squared plus 9 out of 2 x minus 2 y plus 2 equals to 0. Simply divide all the terms by 2. So this is now going to be the equation of a circle that we shall use. So you come and sketch your circle, and then you say, assuming this is my point of tangency, so that this is my tangent. So this is the point of tangency, for which the coordinates are given here as -2 and 3. This is the point of tangency. So at that point of tangency, I have here -2 and 3. Let me call it point A to simplify our work. This point where the tangent is drawn is, let's say, point B. Now here we have the center, and the radius is perpendicular to the tangent. What are the coordinates of the center? That is the most important thing. What are the coordinates of the center? So you say center C. You can compare this to the expanded equation of a circle, and then you go on to compare terms and coefficients. Then you get A and B as we did. But if you have practiced, then you are seeing that here the coordinates of the center are -9 out of 4 and +1. If you use the method of comparing the terms and coefficients, you get the same values of A and B. So after getting the coordinates of the center, we need to find now the gradient of the radius. Because the radius is a line. This is the radius R. It has 2 points at its endpoints. That is 1 point of the center and 1 point on the circumference, which is the point of tangency. We can use these 2 points to find the gradient of the radius. So the points are -9 out of 4 and +1, and then the point of tangency that are called A, -2 and 3. Those 2 points can give us the gradient of the radius. Then we apply this concept. So let us get the gradient of the radius. That means n is given by changing y over changing x. Then you come and name the point x1, y1, x2, y2. Substitute y2 is 3 minus y1 is 1 out of x2 is -2 minus x1 is -9 out of 4. Then you simplify the fractions. The calculator can help you best. 3 minus 1, and the numerator I'm getting 2 out of -2 minus negative 9 divided by 4. I'm getting 1 out of 4. So the denominator is 1 out of 4. 2 divided by 1 out of 4. I'm getting 8. So this 8 is the gradient of the radius. That is the gradient of the radius. What do we know? We know that the radius is perpendicular to the tangent, but the radius is perpendicular to the tangent. What do we know about perpendicular lines? We know that if two lines are perpendicular, it implies that the product of their gradients, that is, the gradient of the first line times the gradient of the second line, equals to -1, as long as they are perpendicular lines. So let me say the gradient of the radius is m1, so that this one becomes my m1. Substituting for m1, you will have 8, m2 equals to -1. Therefore, what is m2? m2 is -1 out of 8. m2 now is the gradient of the tangent. Therefore, gradient of the tangent is -1 out of 8. So replace is well called here. That is the gradient of the tangent. Now, after getting the gradient of the tangent, and you know the point of tangency, which lies on the tangent as well as on the circumference of the circle, we can then find the equation of the tangent using the point of tangency and the gradient. We have our point of tangency A, -2 and 3, and then we have the gradient of the tangent, which we are calling m2, -1 out of 8. The tangent is a line, thus y becomes mx plus c. This is x, this is y. This is our n. So we need to find c, which is the y-intercept. That is the point on the y-axis where the tangent cuts the y-axis. So what is y here? 3 equals to, our n is -1 out of 8 times x is -2 plus c. So from here, -1 divided by 8 times 2. 3 minus answer. So I'm getting my c as, when you make c the subject of the formula, I'm getting 11 out of 4. This is c. Now when we write in the equation of the tangent, which is a line, we only substitute for m and c. Thus, we shall have y equals to m. M is -1 out of 8. You give x, and then you add c, which is 11 out of 4. So this is the equation of the tangent